Alright, so the last thing, the very last thing is domain of the log and natural log functions. So we're not going to talk about range really right now. We're just going to talk about domain. Now with this, there's one big thing that we need to remember when it comes to our log functions and our natural log functions. And I can't remember what's behind this blue box. Oh yeah, remember logs, like the domain for logs? Remember that was from 0 to positive infinity? Remember that? You remember that completely? Because it doesn't cross the y-axis at all, so your domain is just going to be from 0 to positive infinity. It doesn't equal 0 because it doesn't touch the x-axis. So we have parentheses in 0 and positive infinity. Yeah, so that's the original regular domain. But what we're going to talk about here is where the domain kind of changes because of the transformations that are going on. So another big thing to remember is, hopefully you remember way back at the very beginning, way back at the beginning of the log functions, we said at the very beginning of this log section here, we said that when it came to our b and our x, b has to be greater than 0, it cannot equal 1, and x has to be greater than 0. Cannot equal, pretty much greater, it has to be greater than 0. So b, and also let's write this here, b cannot equal 1. Now that's important. And this over here too, the same thing. X has to be greater than 0. And we know our b there is base e, so e is always bigger than 0 anyway, so that'll be cool. We're done with that part. Now, with this, the biggest part is because the b has to be greater than 0 and the x has to be greater than 0, that makes it so much easier to help us to understand. First off, again, as a refresher, I need to make sure I write this down. Here, b and x are both positive numbers. They're always going to be positive every single time. They will always be positive. Both of those are always positive. And also x is always positive there too. Will always be. So whenever we do our domain for this function, all we're going to do is deal with where x is greater than 0, or this whole function is greater than 0. So as an example here, we have y equals log x plus 3 base 4. To make this is going to be very quick, very simple, very easy. All we're going to do is we're going to take what's right here in this spot, what's with that parenthesis, the x plus something, x minus something, x squared plus something, x squared minus something. We're going to take that spot and we're going to make that greater than 0, because that spot's where x is, and that has to be a positive number. So it's going to be greater than 0. So whatever's in this spot right here, right there, whatever's in that spot, that's what we're going to make greater than 0, and then we're going to solve it out. So here, we have x plus 3 is greater than 0. We're going to solve for x. So we're going to subtract 3 from both sides. We're going to get x is greater than negative 3. And so all we do now is just write that integral notation, and then bam, we're done. We're it. That's it. So here, if we write the integral notation, just go back to a number line really quickly. Just really quickly. We said that x is greater than, so it means we're going to shade numbers that are bigger than that over here on this side. And then we do a parenthesis right there. So our final thing is, and also our infinities, don't forget the infinities, come back into play. So our final thing is just writing it so that it's an integral notation. So we do parenthesis, negative 3 to positive infinity. Bam. And if you can go ahead and do it again like we did before without the number line, and just do the integral notation, you got it. That's it. And that's all the work that is. Just make sure you know how to solve it out. That's it. Alright, so here's the last practice that you're going to have for this section of notes. And then we're going to be done. So here is your practice. You're going to find the domain of number 11, number 12. And that's it. And once you find your domain, you're going to make greater than 0, and then solve it out, and then write it in integral notation. Every single time. So it's going to be very simple and easy. And once you are finished with these two problems, you should have all of them done. It should be 12 in all in this whole second part of the log functions. And once you're done with that, turn that into me, and then I'll give you your homework and everything so you know what to do on that. All right, enjoy.